chapter of motion, I'll go over to light and electricity and magnetism and do some experiments with you. Mohammed Riyan, I'm going to give you a ball. You have to be careful. Hold it. ಮೇಲೆ stretch ಮಾಡಿ, ಮೇಲೆ stretch, ಕೈ ಕೊಡ. Up. Correct? Which ball will hit the ground first, we have to find out. And why? See, the green ball is there. Red ball is just near the earth. And Riyan, put your hand forward and leave. Leave it. Listen that. You have to focus on the ground, where the hill. Again. It's again, this is James ball. You know your chocolate. Huh? Hold. Watch carefully. Focus down. Hit finger. No, it hit frontly with finger so that don't hit each other. Otherwise, I have to get over there. Throw. Did you notice which ball is hitting the ground? However high you may go, you can put a chair or you do, Riyan. Bring it down. This ball is very near the earth. Which hit the ground first. I can keep it 1 centimeter above the ground and still that green ball will come and hit first. Red ball is not hitting. Why? Everything is falling. No? When you leave everything, things fall. Are you able to understand that problem? This is ordinary slinky. You all play with it. It's called slinky. In Marina Beach, Chennai, they sell it for 5 rupees. Children play with it. You know that, no? It's called slinky. I have just attached 2 balls. Can I stand on that? Will it break? I'm just keeping it very near the ground. I'm keeping it very near the ground. The green is up. Just see. Always the green ball is coming down fast. All of you notice it? Can anybody think the reason why? This is there. Both material same. And everything will fall. But the spring tension is still there. It's not rising now.
No, sir. When we leave this, sir.
But the spring tension is always there. Spring also acts up on the ball. Spring is also acting on the down ball.
When you leave the ball, the spring first becomes 0, sir.
Spring? Why it becomes 0?
This is not compressed. See,
It expanded?
it tends back to come to the original.
So it will pull this down.
Pull this down
And this will pull up.
but the force will be higher on this.
Why? Very good. You have made a good attempt. Why the net force is higher on it? So try further. This is one of the most interesting experiments to teach you about how forces act, cancel, work on it. One way of looking at it, when anything is falling freely, it becomes zero weight, correct? So when this is falling freely, when I leave it, this point, that point, all under zero gravity. That means the center of mass of the spring will remain at the same place, no gravity, and it will fall. But this spring is extended now, and there is no weight in that ball, there is no weight in this ball. This will pull it down, that will be pulled up. Understand? It's a very, very fascinating small experiment. All of you will not understand in one time. Make it at home, 5 rupees cost. And try to see what are the forces acting on each ball, on the spring, how does it work. And this is one of the best tutors you can think of. It's a very fascinating small little experiment. Because I have kept it sometimes 20 feet distance. Go over my 3rd floor. I have attached slinky after slinky. One is only 6 inches above, other is 20 feet above. But when I leave it, the 6-inch ball remains at 6 inch. And the 20 feet will come running down, cross it over and hit. So that is the beauty of this experiment. Thank you. Thank you very much. You can take a pen for helping me. Or a pen. Thank you. Now, children, I am going to change the topic. There is a very simple thing I am going to talk now. I have to rush because I can't take much time on one topic. Or normally you have a class of 45 minutes on one topic. And I have to cover the entire science in one topic. Impossible. We are going to deal with a subject called light. Light is a very fascinating subject. Can you see light? Can you see light? Very good. You can only see objects through light, you cannot see light. Wonderful. A pen for you. All of you be knowing that light moves with a tremendously high velocity. There is nothing in the world or the universe which moves faster than light. Are you aware of it? That's true. And it was Albert Einstein in the special theory of relativity who gave this final answer that light velocity is the ultimate. Nothing can move faster than light. Now, from this classroom you started with simple experiment. When you start in the beginning, you learn about reflection, refraction, correct? Acha. Now I come with a very simple problem on reflection. I am coming with a very simple problem on reflection. Reflection. Think it over. Suppose my name is Anup. I put on a nameplate here, Anup. But when I see in the mirror, left becomes right, right becomes left. Why? A good handwriting one, somebody? You write on the board, come. Whenever you stand before the mirror, if you have a nameplate, anything, the left becomes right, the right becomes left. Why? Trans inversion by the mirror. No, you stopped it. You just said trans inversion. Who is doing the trans inversion? Now, this is a very, very interesting question which I faced as a boy like you, and I asked a question. Here is the mirror. down, left, right. Correct? There is no role of gravity. Correct? Down, left, right, all are same for the mirror. Why should mirror choose only to do left, right, not up, down? How does the mirror know? I have to only do left, right, not up, down, because up, down, left, right are the same. Huh? No, go ahead. Huh? No. Listen carefully, all of you. Mirror repair. I have my name plate, Anup Jaiswal. I am standing. When I look at the mirror, left becomes right. Correct?
And by hitting the mirror, we get the reflection.
That's correct. But why it is left, right? Why not up, down? See, up, down, left, right, ella mein same da. Mirror is only changing left, right. Why not up, down? See, use only left, right. No. Plain mirror. Even if I write my lane A-N-O-O-P, it will not become up, down. It will, A will turn, N will turn, O-O-P will turn. Now, this is a very basic question I am asking. Daily you observe, mirror changes left to right, right to left normally. Why only left to right? Why not up and down? How does the mirror know? इन्हें left right change करना, up and down change करना पड़ता है.
Just reflect what is art.
What is?
Art's image or image.
And our image is okay, but why only left right? Why not up down?
But we are moving our right hand means it's about opposite direction.
That's true. But see, the mirror is like this. Left, right, up, down. All are equal. But the mirror is only changing left to right, not up and down. I'll show you. This is, what is the word written here? Code box. If any mirror here, I've got a mirror. Can you hold it? Can you see? Can you focus here? On the mirror? Can you focus here? What is written here? Code box. Correct? Look it in the mirror. Can you see? Can you see? It has become left right. Correct na? Are you able to see it or not? When I look it in the mirror, see? It has become same. Code box. But what happens left, right? Happens left, right.
Because the front changes, the left and right, the action.
But why not up and down? Up and down, left and right are same for the mirror. Very carefully. This is where I'll explain you. Listen very carefully. Suppose my name is like this, code box. And I turn towards the mirror, bring in the mirror. You see it becomes left, right. Why it is lateral? Because I am turning like this. Horizontal. There is another way of my turning. I can put my head down and leg up and look towards the mirror. The mirror is not making you left, right. By practice, we only turn towards the mirror like this. There is another method of turning towards the mirror, putting my head down and putting my leg up, which we don't do. But what has happened, what we do, we attribute to the mirror. We are making lateral transition. Mirror becomes left, right. Suppose I've got a model man. Focus on this. You see, here is a man. If he has to look at the mirror, he can turn like this and look at the mirror. This is a lateral turn. There's another way he can look at the mirror. He can turn like this and look at the mirror. But in day-to-day life, we do not turn like this. We only turn like this. What we do, by habit, we started attributing it to the mirror. Mirror is making lateral transfer. Mirror is not making. But many textbooks write lateral transverse, transverse inversion by the mirror, or lateral inversion by the mirror. Textbook lerke. So these sort of wrong things start coming to your mind. The other thing is, thank you. Matchbox. We normally see in our textbook diagrams what is called ray diagram of reflection, of refraction, incidence. But in day-to-day life, we are not able to see any ray diagram. We presume like that. I have got a very simple device. This is a box of chocolate. The chocolate has been eaten up. And this simple box can be converted into show actual rays of light. How they get reflected, how they get refracted. And you can construct the full magnifying telescope or microscope. The entire ray diagram can be made visible. I'm going to show it a bit, and then you can see. This has become very popular. I don't have time to go in detail, but this has become very popular in many institutions, especially in IIT in Chennai. This is called the Tindal Effect. See, I have a laser pen. You can see the beam. You can see the point there. Do you see the light? You are not able to see the light. You only see the end. Correct? I have got a box here. If I pass it, you can see the beginning. And you don't see the end. Now see what happens. Suresh? Just light one match. I take a matchbox, light it. Blow it, put it, no, don't put it inside, hold it. Just let it melt. It's plastic, no? Over. I put some very little smoke inside. Nothing is visible. But now see what happens. Can you see the light? Can you see the reflection? Can you see the reflection? Angle of incidence equal to angle of reflection. Now, if I fill this with water, half water, and put 1 drop of milk, 1 drop, even less than 1 drop, Nothing will change. You can see this ray inside the water, bending in water. You can have a bigger box with lens arrangement. Instead of one pen, you can have two pens. You can see the telescope enlargement, how it measures, how it changes. The entire optical phenomena, you see, I am not, can you see that? Can you see the ray? Angle of incidence, angle of. And if you fill with water, you can see the bending of the water. Very simple experiment. Chocolate box, one small mirror. Huh? What's a mirror? You find it interesting? Very. So, the properties of reflection, refraction can be seen very clearly by these two simple devices. Just put some water. I brought it, a bigger box. But if I start doing the experiment, it will take away all the time. I can show you the box which I have made. I made this box out of, again, acrylic sheet. This is the vertical line. There is a mirror here. I put some smoke inside. I put the laser. We can see this is the vertical line. You can see the reflection. Then I fill it half with water. Puts a drop of milk. This is called the Tindal Effect. And you can convert into very types of, you can convert your whole microscope, telescope inside a box. You can see you can take it as a science project, how a microscope works, how a telescope works, because it is the understanding of reflection and refraction which led to one of the biggest development of telescope, which Galileo made, and later microscopes with which we were able to study entire thing of biology. Very simple experiments led to that big discovery. Reflection and refraction. There is a third thing which you use daily. How many of you use mobile phones? All of you. And the screen of mobile phone is based on one simple principle of light. Anybody can speak that, gets a reward. One is reflection, refraction, third quality of light. Huh? What is that? Standing, scattering. Scattering is a property of the material on which it reflects. It's only a sort of absorption and emission that's different. Huh? Convergence. That is part of refraction, bending. That's okay. There is one property is called reflection, refraction, bending of light. Third,
Angle of incidence.
angle of incidence, that's okay. Anybody? Magnification occurs because of refraction. Huh? Intensity of life, that's okay. Huh? What is inclination? That is okay, reflection. Third aspect which is used in your mobile phone is called polarization. Have you heard about it? I'll show you a beautiful experiment on polarization. Speak loud. Ray of incidence, that's okay. Ray of incidence, ray of reflection. One is reflection, that is reflection. Other is refraction, ray of incidence, bending of light. Third quality is called polarization. I'll show you. Your cell phone, all screen work on that property. I'll show you how. Huh?
Absorption.
Absorption is not a property of the light, it's of the material. Switch off the fan, light a candle here. And please observe carefully, I am going to show you a magical impact of light. Light will turn into magic now. Just watch carefully on the screen. This is called the polarization of light, and that phenomena is used all your cell phone screens. Your cell phones, your TV have got flat screen. They are so useful because of a very simple property of light called polarization. And I am going to show you that. You light it? I'm sorry for switching off the fan. Please switch off the fan for a while so that I can show you the experiment. एक तो हाँ एक और स्क्रीन था, ये है, इसको निकाल दो. Children, I've got one plastic sheet. Any one of you have gone and see 3D movie in a hall? Many of you would have seen it. They provide you with glasses when you go inside the hall. This is called a polarizing sheet. Very ordinary. I just put it in a stand. You can remove it. There's nothing. All your cell phone screen has got a sheet like this. 3 sheets like this. If you take a broken cell phone, remove the screen. I have removed from a cell phone screen only, rather from a tablet, from the screen of a tablet. I've got another screen here, same thing. Now watch carefully what happens. Focus on the light, on the candle. Wait. See, the camera should be looking at through this, correct? You can see the candle there. Can you see the candle? Good. Now when I put this second screen, see what happens. See what happens. The lamp becomes very dim. Look at that. Same screen, no difference. Both screens are the same. But when it has become very dim, correct? Now I take a third screen. Look at the magic now. I take a third screen. I put it in between. See what happens. You saw the magic? When I'm putting the third screen, the light is becoming bright. Instead of one window stopping the light, 2 windows stopping more, but when I put the same material, third window, the light becomes, instead of becoming dim, it becomes bright. See? Please focus there, focus here. Has it become bright or not? Dim, bright, dim, bright. This is what is used in your cell phone. In the cell phone, they have 2 screens like this, light behind, and in between they have got a chemical called liquid crystal, and it is divided into networks. When I am putting my hand, instead of putting my hand, they pass some current. That current will twist that liquid crystal in a manner that light, instead of becoming black, it becomes again white. And you can see it. I can show that also. I've got a screen from a broken. Can you focus on this? Just focus on this. Correct, no? This is a screen. No light is passing now. I got one electricity generator. Where did I get it? Can anybody identify? He'll get a prize. From a lighter. Too many people answered it, no prize. This is an ordinary lighter. When I pass the current in this, it will become white. Just see. I can't see there, tell me now. Is it color changing? See the color is changing or not? When you pass current in this screen, two polarizing sheet, one in between liquid crystal, current changes, the polarization light passes through. And this phenomena is everywhere. In all your broken cell phone, TV, broken pieces, you can get it. I have taken out from a broken, and this is your mother's lighter with which she lights her gas. This is for producing electricity. You just pass current here. See? See? Very simple experiment. From broken cell phone, this is the broken lighter. What is my message to you? There's so much around you to observe. Even difficult phenomena like polarization, you can do it here. You don't have to go to any book at all. Super. Now I'll have a small session. What is called electricity in magnetism. इसको निकाल लो, इसको पैक कर देना. This is the most difficult chapter. Magnetism was known nearly 2000 years back. There is a place called Magnesia in Greece. The story goes that when a shepherd was walking there, in the horn of the cattle, something got stuck. When he tried to remove it again, it's called, what is it called? Not iron. What is the natural magnet called? Natural magnet found in nature. Anybody knows the name of the natural magnet found in nature?
Sir,
No, not covered. What is the common name? Magnetite is a property. It can be magnetized, it cannot be magnetized. Fe2O3, hematite and magnetite. But what is the magnet called? Limestone, no. Lodestone, come on, lodestone. All the best. It is called a lodestone. How many of you have seen a lodestone? Anybody who has seen a lodestone? I will show you. एक छोटा सा लकड़ी का पीस है, कोई बात नहीं. I will show you first a lodestone. This is an ordinary concrete stone found on the roadside, and on the other side I've got is a lodestone. This is a lodestone. I bought it from Amazon to show it to you. Both the stone looks similar. But if I allow it to rest for a while, stop the motion, and slowly turn my body, now it is shaking. It will take some time to settle down. But if I hold it like this and stand for 2 minutes, both will become stable. Then when I start turning around, one stone will remain as it is. The other stone will show some motion. Because the other stone is affected by the earth magnetic field. In look, they look the same. This is the lodestone. This is an ordinary concrete. This stone is the beginning of, the discovery of this stone was the beginning of the story of magnetism and finally to electromagnetism. Without this stone, no electricity. This is the original stone called the lodestone. How did nature produce magnet? Next question. Anybody who can answer me? How did nature produce the magnet? Huh?
Magnetic waves produce.
Where is the flow of electricity?
Flow of electrons.
Where? Nature, where is flowing? Tell me. In nature, where does flow of electron is there? Huh? You have got something. Anybody who can tell how nature produced magnets? How did this lodestone was formed in nature? Anybody make an attempt? Because answers are very simple but fascinating. Huh? No gravity mass.
Volcanic eruption.
Wonderful. Come over. Thank you. Wonderful. I was not expecting this answer from anyone. I am surprised at the beautiful answer she gave. What happened? Give her a hand. How nature produces magnet. When there is a volcanic eruption, the iron, ferric oxide and ferrous oxide, hematite and magnetite, all these materials in liquid form, they come out. They are in liquid form. Their molecules are freely moving. The earth magnetic field is acting on them. While they are solidifying, they get aligned to the earth magnetic field. And when they become a solid, they are no longer able to get disturbed. And this is how nature found magnets. But one of the biggest discovery was in the same column of magnetite and hematite, they found some magnets facing north-south and some magnets facing south-north. Some were facing north-south, another column of material and then another magnetite, and they are facing opposite. Why? And then scientists came to the conclusion that the Earth's magnetic field is not stable. And every 1,000 or several thousand of years, it may flip totally and change its direction. Even today, it changes its angle a bit. If you go to any airport, you will find the runway number 12. What does it mean? Multiply it by 10, it is 120 degree from north, clockwise. 360 degree, this is north. This runway is 120 degree the pilot knows which direction he is flying. There was a one runway in England, it was numbered 11. That means 110 degree. After some time, that number was changed from 11 to 10 because the magnetic north changed about 10 degrees. So the magnetic poles change accordingly. This was the beginning of the greatest discovery in science, study of magnetism. Magnetism is a magic. It is able to pull or push without touching. There is nothing in between. Action at a distance is like a magic. If I tell you, I can influence your mind from a distance. If I tell you I can make the bottle drop without touching, you'll say, Panamudiya de. Isn't it? If I say any time, I can make this spoon bend without touching it, you'll say not possible. But action at a distance is very common. Gravity acts at a distance. Magnet acts at a distance. This was the beginning of magnetism, one side. Now we come to the electric side. A very simple experiment will tell you the beginning of electricity. बंद कर दो, हाँ, slowly pack it up. Now see again, children. I hope it works. If it doesn't work, I'll tell you the reason. I've got an aluminum can. Can you see it? It's a very big can made of aluminum. I keep it here. I have got a woolen material, ordinary PVC pipe. It's a PVC pipe you in your house you are using for supplying water. If I keep the pipe this side and pull the pipe, nothing happens. Why? The pipe is on the other side, it cannot pull the aluminum. But if I rub it, you have to explain fully why it is pulling this. You are right, static electricity, but why is it pulling the aluminum? It repels, but there is charge here. What is the charge there? No, I'm not touching it. That's true. That is the beginning of static electricity. But why is it pulling it? Again, see it carefully, very, very carefully. Don't be in a hurry to answer.
Aluminum have negative energy or the
Aluminium doesn't have a negative energy. Aluminium is neutral.
when we are rubbing it,
I'm not rubbing the aluminium. I'm only rubbing the PVC pipe.
PVC pipe, the electrical thing is observed.
Read a bit more. See what happens. Everybody is eager to answer. Before you answer, frame the question in your mind. What is required? Here is a PVC pipe rubbed by wool, by choice, by mistake. You are removing woolen clothes from a box. They are rubbing. People have got injured while removing their sweaters. Gases have caught fire. Explosive have caught fire because you are removing your coat in front of the explosive. If you go to Kovilpatti, all the people working in Patta's shop, they are wearing electrostatic chargers because the body develops electricity and the charge will go in the powder, it will explode. But why? You see again very carefully what is happening. Here is aluminum neutral. Here, if instead of aluminum I keep a PET bottle, it will not happen. I rub it here. Bring it near. What is happening? I will try. Yes. Huh?
When you rub the PVC pipe, charges get created. Because of the charges, electricity will be created. Magnetic field produces it. Magnetic field
Magnetic field doesn't act on aluminum. Aluminum is non-magnetic. Yeah, that's okay. But why pulling them? Can is neutral. Positive will not attract neutral.
Producing the electron.
That's okay. That's okay. But why is the can?
That can is observing the electron.
Sit down.
when we rub the wooden cloth with the PVC pipe, the attract electron from the
That's okay.
and when we keep near the can, electrons in the PVC pipe attracts the aluminum can.
Why should electron matter? If I keep, instead of aluminum can, if I keep a plastic bottle, it will not happen. Sit down. Huh?
Triboelectric charge.
Yeah?
Triboelectric charge.
Tribo? What is tribo?
Is a charge conductor.
Is a conductor, not a charge conductor, only a conductor.
Conductor.
Then,
Oh.
then answer it further. I know I'm very happy, madam. They are trying hard. This is what is required in science, not correct answer. Try it, think it, attempt it, fail. Attempt it again, fail. Attempt it again, fail. But try. I'm very happy with the class for that. I'll tell you the answer because the time is low little. I have to have another session with you. If the principal invites me next time, I'll come again. Because handling 500 children in one class is difficult task. Anyway, I'll tell you the answer. Answer is very simple. See, if instead of aluminum, I keep a plastic, nothing happens. Why only for aluminum? And the answer lies in the high conductivity of aluminum. I tell you how. When I am rubbing the woolen cloth on the PVC, this woolen cloth is able to rub off some of the electrons from the PVC pipe. It becomes positively charged. When I bring near it, because of high conductivity, the electrons of the aluminum start moving towards it, making this box polarized. Positive charge, negative charge coming this end, and the positive things remaining behind. Because now this end has become positively charged because of induction of, it starts following it. But this is not a conductor. The electrons are not able to move. Electron movement occurs only in a conductor. This is a highly good conductor. If I use iron, it will not work well. If I use silver, very well. Because silver is a better conductor than aluminum. And so that is the reason. And finally, the most beautiful thing happened in electricity and magnetism when Michael Faraday was able to combine magnet and motion and produce electricity. Magnet was known, electricity was known, not in form of the generators you have today. Electricity was known in this form. See, I have got this combination of copper and zinc plate. One piece, I can open it for you. You can see it yourself. No time. Just hold it, man. You see, I've got sheets of zinc, copper, zinc, copper, zinc, copper. And in between I put a flannel. If ordinary cloth, cotton cloth, if I put lemon juice, vinegar, even spit on it and connect it to a bulb, the bulb starts lighting. This is called the Voltaic cell. Voltaic cell produced by voltas. This is called the Voltaic cell. Ordinary copper, zinc, copper, zinc. In between you got cotton. After connecting in parallel, put some lemon juice, vinegar, even your spit. It will start producing electricity. You can light a bulb. You connect it to the bulb. You have that? Oh, thank you. Where is that? I kept somewhere. Now this is the most fascinating thing of electricity, what started with Faraday. Just hold it. Just hold this. Show it. See, I've got a copper coil. Can you see that? I've covered with some plastic to protect it. It's just a coil of wire 2000 times put around, nothing else. At the end of the coil, I put a bulb. Hold it. I put a tube in between, all made at home. And I got a piece of magnet. I put the magnet here, close it, hold it like this, show that light here. I'll just move it. You see, come here. Just a motion is produced. This is the simplest generator of electricity. And this was one Michael Faraday showed it to the King of France. He told him of what use it is. Michael Faraday did not have a light. He had only a magnetic needle, and when he was shaking it like this, a magnetic needle was moving. The king laughed at him. And today you cannot live without electricity. Very simple things led to technology is different from science. Science is the basic understanding of the phenomena. Technology can exist without science. And many of your toys are very good technologies. I'll show you. बच्चे तो खूब पार्टिसिपेट कर रहे हैं ना? Yes. You see, many of you must have played with this boat. Have you seen it? It's a put-put boat, they call it. Very ordinary boat. You play with it. You have a candle. You light the fire, keep it inside, and the boat starts running. Huh? You will not believe it. People have done their PhD on it. Their doctorate degree on the engine of the boat. How does this engine work? You must have seen it. Now, I have designed the engine, very simple engine of the boat, from a insulin injection, just a simple glass tube. There is a tube here, I fill it with water. I put this end in another beaker. I light a candle below. You can see how the engine works because it is transparent. So like this, by observing, you come to know, and I have seen some papers written on it. People got PhD degree on this, working on this boat. इसको पैक कर दो. ये तो आया नहीं कुछ नहीं.
आ गया.
हाँ, sufficient. My confusion starts now because I'm running out of time, and what to show, what not to show, where to stop. What is the time now? So I'm good. So we got only half an hour. 3:30 we are ending. So before I say anything you want to ask, please. If you want to ask, tell me.
In the magnetic field at first, because the molten.
How?
The Earth attain the magnetic field at first.
Because of the Earth molten structure, there's electric current virtually flowing inside the Earth. How is not known? Because of the molten structure, there's lot of, when the Earth was created, the spinning of the ferrous material inside the Earth started producing electricity. How, it is still not known. And because of the circulation of current inside, a pole is being produced, and there's a lot of turbulence going on. That's why the pole keeps shifting.
Planetary positives. Because of the force it is going around, sir. But the gravitational force acts on all the sides of the sun. And why can't this side is more stronger? And,
What mean?
why can't this side attract this side? The gravitational force is all around the sun.
All around the sun. If the planet is here,
Yes, sir.
it gets attracted like this. The planet is here, it gets attracted like this.
Yes, sir.
That's true.
So if the force is more, it is going around the sun, sir. And why can't it attract that?
No, it is attracting all sides. That's why we take the combined effect. The forces cancel with each other, add with each other, called cancellation of forces, addition of forces. Force is a mathematical concept. It doesn't exist. Can you see a force? Can you smell a force? No.
But any accelerating particle must lose its energy, no, sir. But,
Why?
sir, yes, sir.
It is gaining energy when it's accelerating. Is losing energy when it's,
Sir, but at some point it will emit all its energy, no, sir. Sir, but at some point it should emit all its energy and it will.
what? A charged particle.
Yes, sir.
That is not happening because of the quantum effect. Particles, energy, if it was continuous, it will lose energy, keep falling, fall down. But finally they found energy comes in packet, called quanta. And unless the loss is 1 quanta minimum, it will not lose, even if it's a charge particle. Is energy packet. Quantum physics, when you start learning, will come to about quanta. It is as mysterious as energy. Anything else you want to know? Because I like to wind up, half an hour is left. Tell me.
Or believe that quantum physics is a base to create teleportation and time machine.
No.
Can you say about something, sir?
Einstein never said that. Einstein never believed in quantum mechanics. Newton never knew about quantum mechanics.
Sir, in Google only.
Google, don't study your science from Google, because Google has got lot of information, lot of misinformation, lot of disinformation.
Sir, I have to get the
Right information from the right books. For example, there is one book, you can write down the name. The name of the book is 1, 2, 3, Infinity by George Gamow. 1, 2, 3, Infinity. George Gamow is a Nobel laureate. very renowned scientist who writes for children. 1, 2, 3 is available on the Amazon. 1, 2, 3 Infinity by George Gamow. Read that book. Thank you. Huh? Gamow, G-A-M-O-W.
Earth, sir.
Huh?
If it is what is the shape of the Earth, sir?
Huh?
If it is spheres, how the maps are formed?
Maps are found always on the circle. Then when you are flattening it out,
It's not possible.
it's not possible. That's why at the pole everything has to meet longitude. But if you see a flat now, they are parallel. It is only an approximation because your book is two-dimensional. How to carry it? That's why I always read the map from a globe, not from a map. But small place is okay.
Orbit the sun in a circular path or elliptical path?
Elliptical.
Sir, you show an experiment.
No, that was not an actual gravity, no? Gravity changes with distance. This is a fixed. It is only to show radial.
Okay, sir.
It's approximation.
Okay, sir.
Beginning, you asked a question that which revolves around which one is sun revolving around the earth or earth revolving around the sun?
Both is correct. What is mathematically convenient, you do it. For some problem, it is better to keep the earth stationary and move the sun. For some other problem, keep the sun stationary and move the earth.
Sir, while I'm going traveling in the road, I have saw the plane, sir. It is standing in the same place, sir. It is standing in the same place while flying, sir. How it
Which one?
airplane, sir.
Airplane will never stand in one place.
But I saw, sir, before
It appears like that depending on the direction. For example, if the plane is coming straight at me, it will look stationary. But if it's going like this,
sideway, I saw it sideway only, sir.
then it must be a helicopter.
No, sir, airplane only.
And no, not possible.
Sir, the laser you put ray at the box, no, sir. Inside the box, why is the ray sword?
It's, it is called Tindal Effect. There are smoke particles which are scattering. I put some smoke now, see matchbox there.
Earth gets its magnetic field.
I told you when it was formed, it was molten. And there is some sort of circulation of magnetic material, iron material, which is charged, which is moving inside. And that is causing like a coil producing the field, but it's not certain. क्या हुआ बंद करें 15 minutes more हाँ 15 minutes more हाँ छोड़ दे बस करें हाँ so should we continue or any questions they want to ask because Acha, I am going to ask some questions for you very simple questions. Those who give a right answer, very simple question, so simple that you laugh at me. But think and answer. I am standing in Coimbatore, here in the school. I go 500 meters north. Listen to me. I go 500 meters north. Then I move 500 meters east. Then I move 500 meters south, and then I move 500 meters west. Where do I reach? Are you sure of it? Good. Now again listen to the question. I am standing in Coimbatore here. I move 500 miles north. I move 500 miles east. I move 500 miles south. I move 500 miles west. Where do I reach? I'm not hearing the same voice. All are keeping quiet, thinking that there must be a trick. You tell me what is the answer. Again I repeat, I am standing here. I got a very sharp compass, very good compass. I go 500 miles north straight in an aeroplane. Immediately take a right degree turn. Go 500 miles west. Then take a turn 500 miles south. Then 500 miles east. Where do I come? Where do I reach? Whether I reach the same place or not. Why not? Huh?
You will reach south because you started from north opposite directions.
Hmm.
Said west.
No, same. See, north, west, south, east. I'm using all the four directions. First I go 500 miles north, 500 miles east, 500 miles south, 500 miles west. Where do I reach? See, I start. You listen to me carefully. Understand the question. I'm standing here. I fly 500 miles north. North, south, west, east. I am standing here. I go 500 miles with the help of my GPS system. I got a GPS system. 500 miles. Then I turn towards east. Again 500 miles. Turn towards west, south. Again 500 miles. Turn towards this place. Again 500 miles. Where do I reach? Same place. How many people feel it's a different place? Why? Huh?
Our Earth is not flat, sir. It's sphere, sir.
Ah.
Due to this, 500 mile was a longer distance, sir.
Oh, wonderful. Have a prize. There's a simple question. See, like this. Your latitude runs east-west parallel. Your longitudes run not parallel. Earth's, this is the North Pole. The longitudes are running like this. I go 500 miles, but when I go along here, then this will go this way. These lines are not parallel. You understand? On a globe, when you draw your line, take a globe and draw your line, you will find that you are 100 miles away from your original. Understand? Very good. I another give a mathematics problem, very simple problem. A man is carrying heavy stones in a boat across a pond. Listen to the question, very simple. We have a pond here. A man has a boat here. The man is carrying a very big load of heavy stones and is taking across the pond. He comes to know these stones were not required. He finds it, he wants to throw them down in the pond. He pushes all the stones inside the pond. Will the level of water in the pond go up, go down, or remain the same? Listen to my question carefully and then answer. Here is a boat. The man is sitting here. A lot of stones are here. He pushes the stones inside the water. What will happen? The stones will drown, sink, fall down. Now the level of water in the pond, will it go up, go down, or remain the same? Remain the same. Why?
Sir, that same stone only we are taking in mind. And that same stone only we are...
Wonderful, not right answer. Anybody else? Why?
Buoyancy,
Not correct.
because the boat is already in the pond.
And then?
So the same level, sir.
No,
Sir, the pond water will rise up since the pond.
no. All of you have given a wrong answer. The answer, wait a minute. The answer go up, remain same is wrong. Obviously the third answer is right, go down. But why go down, you find it out. The water level will go down. Why? Once you think about the Archimedes principle, you will get that answer. Think carefully. Don't be in a hurry. Water level will go down. Why? You leave it to you. I have given you the answer, but you have to find the reason. Correct? Should you have some more problems, or that's all? I think, ma'am, because if I start another topic, it will take another time. Should we wind up? What do you think? Huh? Okay, that's what I want. Because I've got so much material that you can empty it there. अरे इसका एक और कॉर्क था. See, I had got so many material, I could not show to you. I was talking about air pressure. There is a cork there. As a pointed cork. See, this is a very simple device, a small pump. But to show the properties of air, conservation of energy, if I give you this cork and you throw with full force, it may fall somewhere here. But if I put the cork on this, it flies very high. So what is the reason for it? Hand is the same, power is the same, why it makes it go so far? The answer is different. When I throw something with my hand, this is 50 gram, my hand is 1 kg, I am spending to give lot of velocity to my hand. So 1 kg velocity, 1 kg is taken by my hand, only 50 gram goes to this. So most of my energy is wasted. When I put it like this, the velocity gets converted into a potential energy of a pressure in the gas, and when gas releases it, it takes very far. So if you try with full force to throw it, it will not go that far. But you just put it in a pump and pump it, it goes very far. So these aspects which you do observe daily.
Before question, so I can answer that question. Sir, because the equal amount of water, so sir, for that stones, the equal amount of water will rise up and fall out, so the water level will down.
Not rise up or fall down where? No outer. Pond is big enough. No outer. Not going out of the pond.
Sir, the weight of the stone is equal to the amount of water displaced from the pond, sir. Hence the level decreases.
Weight of?
The weight of the stone is equal to the amount of water displaced from the pond.
That's okay.
Decrease in the
Why? Hence, I'll tell you I want the answer because you're coming near it, but you're not right. People want to have the answer. See, when an object is floating, the amount of water displaced is equal to its weight, correct? Then only an object will float. When the stone is in the boat, it is floating along with the boat. So what is the water displaced by the stone itself is equal to its weight. When the stone is thrown inside, the water displaced by stone is equal to its volume. Because the volume of the stone is much less than weight because density is more than 1 of stone. So in the second case, displacement of water is less. If less water is displaced, the water level will go down. That is the answer. But these are very simple questions, but very tricky. It makes you think. We'll wind it up.
Thank you, sir. Thanks is just a word, not enough to show our gratitude to you. And instead of them, the science is very easier to learn if the concept is clearly understood. With your simple models, you have made many things clear, right from the concepts of motion, light, magnetism, and many more, in just 2 sessions. The little children are really blessed to have listened to you, sir. Thank you very much. So requesting the dignitaries to occupy the dais.
Now, we request the chief guest of the day, Mr. Anup Jaiswal sir, to give the certificates to the participants from various schools. We call upon one by one. We request the faculty and the student to collect the certificate. First one, PSGR Krishnamal High Secondary School, Ms. N.R. Gayatri ma'am and Shifana M. Next, Kamarajar Matriculation Higher Secondary School, Burmi ma'am and Maharajan. Shri Ramakrishna Matriculation Higher Secondary School, Nava India, D. Geeta ma'am and Aditya. Shri Bal Devdas Kikani Vidya Mandir Matriculation High Secondary School, Caroline Pravina R and Gopi Krishna G. Next, Venkatalakshmi Matriculation Higher Secondary School, D. Rekha ma'am and Srijit. Shri Jayendra Saraswati Vidyalaya School, K. Lavanya ma'am and Subiksha. St. Joseph's Matriculation Higher Secondary School, Jasila ma'am and Muttu Raghavan. Sindhi Vidyalaya Matriculation Higher Secondary School, Anbaras C and Raksha. Perks Matriculation Higher Secondary School, Angel Infanta ma'am and Kanika Devi. Shri Ramakrishna Central CBSE School, Rajesh Kumar P. sir and Vishnu Priya. Shri Ramakrishna Matriculation Higher Secondary School, Vattamalayam Palayam, S. Nitya ma'am and Srimati. Hindustan Matriculation Higher Secondary School, Mrs. C. Nitya Bhargavi and Ansaf. TNGR Memorial High Secondary School, P. Manikam and S. Sanjay Kumar. PSG Sarvajana High Secondary School, K. Shankar Ganesh and Jeevanandam. Thank you, dignitaries.
We must find time to stop and thank the people who make a difference in our lives. I request Dr. Sashikala, Head Department of Chemistry, to propose the vote of thanks.
Happy afternoon to all present here. It's my pleasure to propose the vote of thanks in this auspicious occasion. On behalf of Department of Basic Science, Physics, Chemistry and Mathematics of Sri Ramakrishna College of Arts and Science, Coimbatore, I feel proud and privileged to thank the chief guest of the day, Mr. Anup Jaishwal, former DGP, Tamil Nadu Police, for accepting our invitation and for giving an excellent workshop on facts of science, a funny learning, and for kindling the interest for basic science among the young minds. Thank you, sir. I would like to take this opportunity to place a record of hearty thanks to our management for the guidance and support rendered in all our occasions. My sincere thanks to our beloved Principal and Secretary, Dr. B.L. Shivakumar, sir, for his constant support and encouragement to organize this kind of programs. Thank you, sir. My special thanks to Mr. Mutturaj ASP and to Mr. Suresh for accompanying Anup, sir, to make this workshop a success. Thank you, sir. My heartfelt thanks to all the principals of various schools for accepting our invitation and have sent their students and made this workshop a grand success. Thank you all. My thanks are to the faculty members of various schools who all came a long way with their children, cooperated with us and supported to conduct this workshop successfully. Thank you, teachers. My special thanks to all the head and faculty members of Department of Physics, Chemistry and Mathematics for putting their effort, hard work and involvement with their cooperation to make this workshop a memorable one. Thank you all. My wholehearted thanks to the children from various schools for their active participation and a thirst to learn the concepts in science which made our workshop a complete one. Thank you, children. I would fail in my duty if I fail to thank the faculty members of technical team for their timely support and all the non-teaching members for the support they rendered. Thank you all. Last but not the least, my genuine thanks to all the students of Department of Physics, Chemistry and Mathematics for the involvement in this workshop as volunteers and also as participants. Thank you all, one and all.
Let us all rise for the national anthem. Students, please be seated.